The effectiveness of a cross-curricular approach to teaching has been the subject of intense debate throughout the history of the education system. Savage argues that all subjects have links to others, and the transfer of skills and knowledge from one to another promote an enriched pedagogy that is essential for cognitive, personal and social development. However, commentators such as Alexander question the complex classroom practices that reside in the primary environment, arguing that subjects have lost their focus, which has resulted in learning that is superficial at best. This presentation will focus on the issues surrounding cross-curricular teaching, whilst paying special attention to its influence on the special relationship between maths and science. It will then go on to analyse the use of ICT, before finally looking at how important the cross-curricular approach to teaching is in modern education. The idea of cross-curricular teaching was first introduced as a result of the Plowden Report in 1967. Plowden argued that knowledge does not fall into neatly separated compartments, and that work and play are not opposite but complementary. This was the first time that skills were thought of as interchangeable between subjects. The report was dismissed at the time as Labour had just come into power, and the report was commissioned by the Conservatives. However, in years to come, the recommendations in the Plowden Report would become the norm in modern education. Towards the end of the 20th century, education would be steered towards subject learning, with the introduction of the National Curriculum and the Education Reform Act of 1988. A back-to-basics approach was desired by the Conservative government, as standards, especially in literacy, were dropping, with the blame being placed on teachers who were seen to be neglecting the basic skills in their approach. This was the finding presented by the three wise men, who wanted subjects to be more defined, further reinforcing the idea of the national curriculum. However, criticism has arose about the information in this report, as none of the men involved went into any schools, and the report took only 6 weeks to compile. Cross-curricular teaching became a hot topic again in 2009, with the publication of the Rose Review. Jim Rose, one of the three wise men, published a report which highlighted the importance of cross-curricular teaching in terms of skill and knowledge acquisition. His report suggested that students learn best when the skills they learn in subject-specific lessons are applied across the curriculum in given context. The report also suggested that teachers are already implementing a cross-curricular approach to their teaching if it aids the learning experience of their students. Learning in schools is all about acquiring a range of skills and knowledge that are essential for modern working life. Every child in the United Kingdom is entitled to a free education, which should provide them with the opportunities to work towards any chosen career. This view is shared by Boyle and Bragg, who believe that the curriculum to which children are entitled should be coherent, broad and balanced. Webb argues that the national curriculum is too limited in its approach to teaching, leaving lessons segregated. Providing a cross-curricular approach allows for an abundance of opportunities for children to develop skills and concepts that apply to a number of subjects, including maths, English and ICT. One of the main arguments behind offering a cross-curricular approach to learning is that students often struggle to apply the skills they have learned because they do not understand the context in which these skills can be used. For example, in maths, students learn skills such as data handling and drawing graphs, but without real-life data, these skills lose meaning and just become another lesson rather than a skill that can be used in so many different avenues. By applying these skills in science, students get a context for the skill and therefore reason to apply and acknowledge this information. The Rose Review of 2009 offered a number of reasons why a cross-curricular approach to learning is essential in modern education. Rose argued that the best skill acquisition is brought about when students have content brought to them in high-quality subject teaching mixed with application of such content across the curriculum. The cross-curricular approach allows students to constantly apply skills they have learnt throughout the curriculum, therefore constantly reinforcing their knowledge. The report also suggests that applying knowledge and skills across the curriculum helps students understand real-life issues such as citizenship, sustainable development, financial capability, and health and well-being. Ross argues that a cross-curricular approach to teaching should only be implemented for the enhancement of existing and real links between subjects. Trying to integrate all subjects can cause confusion for students in terms of the skills and knowledge they should be acquiring in a given lesson. For example, in science, skills such as planning, presenting evidence and evaluating data are seen as subject-specific, and and as a result of a cross-curricular approach to learning, these skills may not develop to the level expected. This can lead to subjects losing their identity and meaning, which completely goes against the structure of the national curriculum. However, the national curriculum has been the subject of criticism for the amount of content that is expected to be taught against the amount of time available in the school year. This means that teachers have to use a cross-curricular approach simply in order to meet demands of the national curriculum. As a result, the approach is being used simply to meet time demands rather than being used appropriately for the acquisition of skills and knowledge. Maths and science have a strong bond in terms of how they link to one another. Many of the essential skills required for scientific discovery and analysis are derived from the numerical language that is taught through maths. Throughout Key Stages 1 and 2, students will learn skills such as drawing graphs, calculating averages, calculating percentages, measuring units of length, time, volume and area, and data sorting and handling. All of these skills are essential for scientific inquiry, making maths essential for the teaching of science. Westwood argues that students require basic mathematics skills for even the simplest of scientific experiments, and that students who struggle with maths will experience the same struggles in science, therefore causing learning issues across the curriculum. Research has shown that collaboration in planning for science and maths aids the acquisition of skills and knowledge, which ultimately leads to higher marks and pass rates in all methods of testing, such as SATs, GCSEs and A-levels. In terms of future employability, the need for a strong ability to do science and maths has never been higher. This is due to the nature in which business is conducted in the 21st century, with technology being essential for trade and growth. ICT plays a major role in all areas of education, but it is the responsibility of the teacher to make sure that its incorporation is aiding learning. The inclusion of the interactive whiteboard has been a major benefit for teachers. The interactivity can be used across a range of subjects and can be used to give students more hands-on involvement. For example, in maths, students can use the whiteboard for solving sums, organising numbers, creating patterns, and looking at number factors. Using ICT in maths has been shown to enhance collaboration between students, as well as increasing focus and motivation through the use of instant feedback. In subjects such as science, where students often lose interest in what they are studying, ICT can be incorporated to rebuild focus and offer more control over the learning experience. However, ICT is most beneficial to science and maths through data logging. Data logging allows for data to be collected quickly and accurately, which can dramatically improve the quality and accuracy of the results recorded. Osborne and Hennessy argue that data logging adds an element of flexibility in lessons, allowing students to collect data over a period of weeks or months. The merits and drawbacks of a cross-curricular approach to teaching are clear to see, and the debate about its effectiveness in modern education will continue to play a major role in how governments dictate their education policies. From the evidence provided, it is clear that the advantages far outweigh the disadvantages, and that its incorporation is paramount for the acquisition of skills, knowledge and concepts. However, the responsibility for its effectiveness lies with the teachers, so all planning must be carefully thought over to make sure that in each circumstance the approach is aiding learning for each individual student in the class. It is important for teachers to make sure that mathematics skills are practiced wherever possible, to make sure that all students are able to master its numerical language. This skill acquisition is essential for all areas of work and life in this technological 21st century. Science and maths share a unique bond compared to other subjects within the national curriculum. Science is not possible without math skills, although maths does not need science for effective teaching. What science does bring to this partnership is hands-on experience, which stimulates the mind and is far more interesting for students than solving simple math problems. Bringing skills into real-life problems aids the learning and gives the students a context in which they can not only see why they need such skills, but also how to apply it and when.